Hello everyone. In this video, we are going to test if the given functions are inverse of each other. And this is the second part. I will put the link of the first part in the description box below. Before we jump into this example that we have right here, we always remember this. Two functions f of x and g of x are inverses of each other if both f of g of x and the g of f of x are equal to x. So what's going on here is that we are going to determine first the f of g of x. I'm just going to go ahead and write that up here. Okay, so if we say f of g of x, that means that this g of x right here, so this part of the equation will be put into the f of x, or the x of the f of x. So this equation would come out. So we're going to start by writing the f of x first, and then we plug in this one to the x. So this would come out 2 over 3. And then we give away for the g of x right here, which was the x. And so that's a minus 1. So again, inside this parentheses would be the g of x. So I'm going to write 3x plus 3 over 2. So what I did was I plugged in the g of x into the f of x. And then we're going to simplify this. So then we can go ahead and distribute this 2 to each term inside the parentheses. So that would be 2 times 3x and 2 times 3. So that would come out 6x plus 6. So that's 6x plus 6. And that's over 3 times 2 would be, so again, we distribute this one right here. 3 times 2 is 6, and there is still a minus 1 at the end. So then we go ahead and simplify this fraction first. We remember that this 6 is the denominator for both of them. So this is shared by both of them. So then we can go ahead and simplify this as that's gonna be 6x over 6 plus 6 over 6. And that's a minus 1. And then from here, we simplify it some more. 6x over 6 is just x. Plus 6 divided by 6 is 1. And then that's a minus 1. So the leftover, so these two gets crossed out. So the leftover is x. So our f of g of x is equal to x, which is a good sign since our target is to determine if the f of g of x is equal to x. Since this one is equal to x, we will test the other one because again, remember it has to be to both of them. So then we go ahead and move on to the other composite function, which is the g of f of x. So I'm just going to write that down here. That's the g of f of x. Okay, in order that we can compose this g of f of x, what's going on here is that the f of x will be placed into the g of x. So this f of x right here will be placed into the x of the g of x. So then our equation would come out. So we're going to write the g of x first. So that is 3. So I'm just going to write this in because that's a fraction right there. So I write 3 times, then I will give way for the f of x, that's the x right there, and then we have a plus 3 after that, and that's over 2. So then our x was actually the f of x, so which is 2 over 3x minus 1. So then we go ahead and simplify this. We remember that this one has an invisible denominator of 1. So then we can distribute this 3 into the terms inside the parentheses. So then our equation would come out. So first we are going to multiply 3 times 2 is 6 over 1 times 3 is 3, and there's an x there. And then 3 times negative 1 is negative 3, and then we have a plus 3. And that's over 2. So then we go ahead and say that this, we can still simplify this. So this would come out 6 divided by 3 is, so I'm just going to write that down here. So that's 2x, and then negative 3 plus 3 is a 0. So we don't need to write that. So then that's over 2. So then we go ahead and say that, so 2x divided by 2 is just x. So then our g of f of x is actually x. So again, we remember two functions, f of x and g of x, are inverses of each other if both f of g of x and the g of f of x are equal to x. So in this case right here, both of them are equal to x. So then we can go ahead and say that these two are inverse of each other. So I'm just gonna write it down here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we remember that two functions f of x and g of x are inverses of each other if both f of g of x and the g of f of x are equal to x. So in this case right here, we're going to start with f of g of x. Okay, so this f of g of x means that this g of x, so this equation right here will be placed into the x of f of x. So that means our equation would come out. So I'm just gonna rewrite that up here. So that is, that's where we put the x here. And then there's a plus 2. And then that's a cubed. And that's a minus 1. So then we go ahead and plug in this g of x into the x. So this is equal to the cube root of x minus 1. And then there's a minus 2 at the end. Okay, so what I did was I plugged this into the x. And that's how it looks like now. It is in red. So the g of x was in red. So what are we going to do now is we can cross out the negative 2 and the positive 2. So we can cross that out. So then we are left with, we can simplify this as, that's the cube root of x minus 1 cubed minus 1. Now remember that if we have a cube root and a cubed, we can cross them out. So these two gets crossed out. So we are left with, that's gonna be the x minus 1 minus 1. So then this is equal to x minus 2. Now please remember that two functions f of x and g of x are inverse of each other if both f of g of x and the g of f of x are equal to x. In this case here, the f of g of x is not equal to x. So I'm just gonna label that right here. This means that if it is not equal to x, this means that these two are not inverse of each other. So just a reminder, if you can already have one of them to be not equal to x, just like this one right here, you don't have to move on to the other composite function, which is the g of f of x, because it has to be both. It has to work to both of them. So if you're able to determine that one of them is not equal, so you don't have to do the other one, because it has to be to both of them. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!